And I'm very happy to have with us today Julia Stoyanovich. So just a few words on Julia. She got her master's and PhD from in computer science from Columbia University. And she's the recipient of NSF Career Award. She's a senior member of the ACM and a professor of computer science and engineering at the Tandon School of Engineering and associate professor of data science at the Center for Data Science, and also director of the Center for Responsible AI at the, all of these positions at the New York University. So in her research, she focuses on responsible data management and analysis. And she has established the Data Responsibly Consortium and also served in the New York City Automated Decision Systems Task Force, appointed by the mayor of New York, and who did lots of work on the field in this very interesting problem. So without further ado, let me give the floor to Julia. Thank you very much for being with us today.
Thank you, Temis, for having me and for the introduction. I'll share my screen, at which point I won't see any of you. So if there's anything with anything technical, please speak up. So the first thing is, could you confirm whether you're seeing my slides with notes or without?
Without notes, it's perfect.
Okay, great. So I'll start, and if any burning questions arise, of course, please feel free to just speak up, because like I said, unfortunately, I don't see the audience. And then we will have a discussion also at the end. So once again, it's my pleasure to be here. And today I will discuss a topic that is near and dear to my heart, and that is what are the challenges and the potential ways to address these challenges in designing, developing, and deploying data-intensive systems responsibly. And as my title suggests, I will be linking these challenges to the concept of equity. Equity as a social concept is about treating people differently depending on their endowments and needs to provide equality of outcome rather than equality of treatment. And it lends a unifying vision for much ongoing work to operationalize ethics and legal compliance across technology, law, and society. And I will present here a vision for building such data equity systems that consider equity as an essential objective. My talk is going to have some technical content, but essentially it's aimed at the general audience. And I'm happy to discuss some of the more technical points or the less technical points later on as well. So to start, let us all agree that AI is simply great. The convergence of unprecedented data collection capabilities, enormous computational power, and broad acceptance of data collection and analysis as a way to move society forward are offering us tremendous opportunities to do good. We can accelerate science and boost innovation. We can transform how governments function by making resource distribution more equitable and by bringing greater transparency and accountability to government operations. And perhaps most importantly, we can get AI to do all of our work so that we can just sit back and relax at the beach. And I like to think of AI as a system in which algorithms use data to make decisions on our behalf or help us humans make decisions. This, of course, is not a definition that everybody is going to agree on all the time, and I sometimes disagree with this definition as well. But for the purpose of today's conversation, I'd like to adopt this definition. And I'm showing here some examples that support my definition, and these are Roomba, a robot that helps us clean, a chess-playing AI, a self-driving car, and an automated hiring system. And there are, of course, plenty of others. So these are just the examples that are sufficiently different from each other and that I could fit on one slide. These examples and many more underscore that we see substantial promise in the use of AI. We look to these systems to make our lives better, more convenient, and to improve ways in which society works. But the reality is that machines make mistakes. For example, a customer service AI at your favorite online shoe store may misunderstand your order, and the wrong pair of shoes will be shipped to you accidentally. And annoying as this may be, consequences of such a mistake are not severe and they are reversible. However, there are cases where mistakes can lead to catastrophic, irreversible harms, even to the loss of human life. Consider an autonomous car as an example. That is an AI that is about to suggest to the vehicle to cross an intersection, and that does not recognize a person on a bicycle as one of the objects that it would expect to see on the road. The car would then continue on its path, running the cyclist over. To dive deeper into the conversation about AI and data equity systems, let us consider a domain where AI is used ever more broadly and where the stakes of a mistake to an individual, a population group, or even to society at large simply cannot be overstated. This is a domain that I've been thinking about quite a bit in recent years, and it's automated hiring. In a 2018 report, Bogan and Enrique described the hiring process as a series of decisions that form a funnel that I'm depicting on the right. It's a system that is operationalized as a sequence of data-driven, algorithm-assisted steps in which a series of decisions culminates in job offers to some candidates and rejections to others. The process starts at the top of a funnel when employers source candidates. For example, they issue ads or job postings. Next, during the screening stage, employers assess candidates by analyzing some details about their application, such as their experience, skills, and other characteristics. This stage uses a variety of AI-based data-intensive tools. These include resume screeners, also screeners for social media profiles like LinkedIn and Twitter. Also game-based assessments where candidates, for example, are told to press the space bar and inflate or pop balloons, and this is then meant to estimate some personality traits of the candidates that presumably are indicative of their success on the job. Next is the interviewing process. So through interviewing applicants, employers will continue their assessment more directly. And at this stage too, AI is very often used. So these interviews are not very often with a human, but rather they are with a machine, and video and speech analysis methods may be used here. Again, to determine which candidates should proceed through the funnel and which should be discarded. Next, I have here background checks. This is one of the steps in the selection process. Here is where employers make final hiring and compensation determinations, and then an offer will go out to those who were selected. And
Julia,
yes.
Excuse me, one question. Do you know how prevalent AI systems are in hiring processes?
They are, in my opinion, ridiculously prevalent, much more so than is warranted. This is my personal opinion. But as far as we know, the majority of Fortune 500 companies use AI, for example, at least one of the stages of the funnel. It's a multi-billion-dollar industry. So this is extremely, extremely common. And as far as I know, these systems are used throughout the world. This is not just a US phenomenon.
Okay.
And because this is just so widespread, this of course is the reason that I'm interested in this domain in particular. Right, so one quote that I like here that kind of brings the message home is by Jenny Yang. Jenny Yang is a lawyer in the United States, and she served as the commissioner of the US Equal Employment Opportunity Commission, or EEOC. This is a very influential federal agency that oversees employment practices from the point of view of discrimination primarily. And Jenny said rightfully that automated hiring systems essentially act as modern gatekeepers to economic opportunity. So why are these tools being used so ubiquitously? Well, first, the hope here is that they will help employers hire more efficiently, source and screen candidates faster and with less paperwork, and select candidates who are likely to do well on the job. And then these tools are also meant to improve efficiency for the job seeker, the job applicant, allowing them to apply with a click of a button and matching them with relevant positions, and then also facilitating the interview process. We also often hear this argument that the use of these tools can help us improve workforce diversity. And indeed, this argument is being made based on the following, that because humans are biased when they hire, we have no choice but to use machines to step in and hire on our behalf, or at least help us in this process. And I'm showing here an excerpt from a very famous study from 2004 that was done by Marianne Bertrand and Sindil Mulainathan, who, again, in the analog days of 2004, manipulated perceived gender and race on resumes that they sent out in response to help wanted ads in Boston and Chicago newspapers. And then they saw which of these resumes received callbacks for interviews. And they observed that applicants who were perceived as male and white received substantially more callbacks. So here I have a quote that says white names in particular received 50% more callbacks for interviews. And this is on the very same resumes, right? So just the name is replaced to sound male or female, white or black. So are algorithmic hiring tools living up to their promise is the question. And one of the earliest indications that there is cause for concern came already in 2015 with the results of the so-called Ad Fisher study out of Carnegie Mellon. In that study, the authors ran an experiment and found that ads for high-paying jobs were shown far more frequently to men than to women. And this experiment was really brilliantly carried out. It wasn't real men and women. It was synthetic profiles of web users who were the same in every respect, demographically, in terms of their browsing patterns, search keywords. The only difference between them was their stated gender, which was binary in this experiment, and it was male or female. And so the male seekers, in quotes, were seeing far more ads for high-paying jobs than were the female seekers, in quotes. And this brings memories of the time when it was legal to advertise for jobs by gender in newspapers. And in some countries, this is still legal, but in the United States in particular, this was outlawed in the 1960s. And yet this practice is showing its ugly head again in this online environment. As another example, and this probably is familiar to many of you, in late 2018, it was reported that Amazon's AI recruiting tool that was developed with the stated goal of increasing workforce diversity did the opposite thing entirely. The system taught itself that male candidates were preferable to female candidates, and it penalized resumes that included the word women's, as in women's chess club captain, and also downgraded graduates of 2 all-women's colleges. There are other examples as well, and new ones are coming up, weekly, if not more frequently. Other examples include discrimination, where people are being shut out from the pipeline, from job opportunities based on their mental illness, such as depression or bipolar disorder, on the basis of online personality tests. And this happens even if they have the right skills for the job. And then another example that is quite striking and also quite well known is that ads were suggestive of a criminal record were shown more frequently when you Google for African-American sounding names than when you Google for white sounding names. And this happens even if you control for whether the individual in fact has a criminal record. And this was surfaced by Latanya Sweeney back in 2012, 2013. And this, of course, is problematic. And I'm bringing this in here because employers very often Google for an applicant's name as part of a background check, as they decide whether to consider the candidate to make them an offer or whether to consider them essentially to advance through the hiring funnel. So to summarize, we are concerned about the use of data-driven algorithmic systems in hiring. Their effects are often discriminatory, despite their promise to the contrary, reinforcing results of historical disadvantage. And this discrimination is often linked to the term bias. And this is a term that I will revisit shortly. It's a term that's used very often by the technical community, increasingly so, but it remains poorly understood. So in addition, or perhaps even before worrying about bias, we should ask whether these tools actually work. Are they picking up useful signal from the data that they are given, or are they an elaborate coin flip at best? I'm showing here Arvind Narayanan. He's a computer science professor at Princeton who gives this brilliant talk about AI snake oil and asks in particular whether AI used in hiring is snake oil. So if a tool helps improve workforce diversity, for example, it admits a sufficient number of candidates of each required demographic group, but its decisions are otherwise arbitrary, can such a tool be considered fair? And if these decisions are worse than arbitrary, what if the tool is picking up signal like a person's disability status from the information, and we have no way to know that this is happening? What if it's measuring something about the job applicant that we have no reason to believe to be relevant for the job for which they are applying? These are all questions and concerns that, that have been raised and that need to be interrogated. So how can we know whether a tool works? Well, we don't need to reinvent the wheel here. AI tools are engineering artifacts. And so we should not take the claim that they work on face. And of course, to us engineers, this is clear. And yet there isn't a practice of checking whether the tools work. There isn't a practice of using the scientific method, which always starts with an observation, is followed by the formulation of a falsifiable hypothesis, one that can be proven false. And next, an experiment is designed to check whether the hypothesis is falsified, and if so, we refine the hypothesis, design a new experiment, rinse and repeat. An appropriate hypothesis in algorithmic hiring is one that helps us ascertain whether the tool indeed selects employees who will do well on the job. And it does, and is better at predicting this than a random guess would be. And to support this visually, I'm showing here Karl Popper, a philosopher of science, who famously said that a theory or idea shouldn't be scientific unless it could in principle be proven false. So the main point I'd like to make today is that it's not up to any one group of individuals to keep AI systems in check. I firmly believe that we all have a role to play here in ensuring that these systems are designed, developed, and used in ways that are socially sustainable and responsible. All of us, technologists, auditors, regulators, decision makers, most importantly, members of the public, are responsible, and we all should be actively participating in this work. So where do we go from here? As a technologist and an engineer, I'd like to understand how to make this issue of the responsible design, development, and use of data-intensive systems possible. And folks have been rushing to produce technical solutions to address some of the related problems. And I am one of these people. But before diving into some of these technical details and solutions, I'd like to return to data equity as advertised and to see how it can be used to help us frame these solutions. That is, I'd like to step back and think carefully about the role that technological interventions, such as data and model debiasing that I'm sure you heard about, can play in this conversation. And this discussion is necessary to help us find a pragmatic middle ground between the harmful extremes of techno-optimism that I'm showing on the left, and that is a belief that technology can single-handedly fix deep-seated societal problems like structural discrimination in hiring, and techno-bashing. I'm showing that on the right here, and there is a belief that any attempt to embed ethics and legal compliance in data-intensive systems will amount to fair washing, and so should be dismissed outright. So to start, and again, as promised, let's return to this conversation about bias. And for this, I like to use the very simple and still useful, insightful taxonomy that was proposed in 1996 by Friedman and Nissenbaum in their seminal paper called Bias in Computer Systems. I'm representing 3 dimensions of bias that they outline as a 3-headed dragon, and the heads are labeled pre-existing, technical, and emergent. Pre-existing bias exists independently of an algorithmic system itself. It has its origins in society. Technical bias is introduced by the operation of the technical system, and it may exacerbate pre-existing bias. Finally, emergent bias arises in the context of use, and it may be present if a system was designed with different users in mind, or when societal concepts shift over time. I'm using here an acronym ADS that stands for Automated Decision System. This is the preferred term in the United States. In Europe, it's ADM, Automated Decision Making. So data equity comes to the rescue. We are going to fight the dragon of bias with the help of data equity that I'm depicting here as a knight with 3 swords. And each one of these swords is labeled with the kind of equity that it represents. So these are the facets, the 3 major facets of data equity that I'd like to discuss and to propose. The first is representation equity. It refers to deviations between the data record and the world the data is meant to represent, often with respect to historically disadvantaged groups. The second facet is access equity. It's concerned with having access to information, features, data, and models that are needed to evaluate inequity. The third is outcome equity. It refers to downstream unanticipated consequences outside the direct control of the system. I will now go through each of these data equity types to give a flavor of the positioning of why this phrasing is helpful. And as will become clear, purely technical solutions will never be sufficient. They have to be based on explicitly stated values and beliefs that in turn arise through public conversation and social consensus. So to start, let's discuss representation equity. To think about this equity facet, I like to use the following metaphor. Data is an image of the world. It's mirror reflection. When we think about representation inequities or about societal bias in the data, we interrogate this reflection. One interpretation of bias in the data is that the reflection is distorted. We may systematically oversample or undersample in particular parts of the world or otherwise distort the readings. Another interpretation of bias in the data is that even if we were able to reflect the world perfectly in the data, it would still be a reflection of the world such as it is today, and not necessarily of how it could or should be. And here I'd like to make a couple of points. The first is that it's important to keep in mind that a reflection, a data set, cannot know whether it's distorted. That is, data alone cannot tell us whether it's a distorted reflection of a perfect world, a perfect reflection of a distorted world, or if these distortions compound. The assumed or externally verified nature of distortions has to be explicitly stated and used as input to technological interventions like data and model debiasing. The second point is that it's actually not up to data or algorithms, but rather up to people, individuals, groups, and society at large to come to consensus about whether the world is how it could or should be, or if it needs to be improved. And if so, how we should go about improving it. This once again limits what we can expect of technical solutions to do on their own. My third and final point is that changing the reflection does not necessarily change the world. If the reflection itself is used to make important decisions, for example, whom to hire or what salary to offer to an individual being hired, then compensating for the distortions at that point of decision is worthwhile. But we have to keep in mind that the mirror metaphor really only takes us so far. We have to work much harder, usually going far beyond technical solutions to propagate the changes back into the world, not just brush up the reflection. So let me now give an example of a concrete approach that focuses on representation equity in set selection and ranking. Set selection and ranking is one of my favorite technical gadgets, and it's also one that is very well applicable to this domain that I used as motivation, and that is algorithmic hiring. Consider the task of selecting 4 candidates among 16 job applicants. Our goals are twofold. The first is diversity, which I'm going to phrase as we wish to include 2 candidates of each gender and at least 1 of each race. The second goal is utility, and that is going to be phrased as maximizing the sum of scores of the selected candidates subject to diversity constraints. You can see a list of candidates in the table here along with their scores. For example, candidate A has score 99 and L has score 83. Observe that male candidates in my example have higher scores than do female candidates of the same race, and that whites have higher scores than blacks and then Asians. The highest scoring set of 4 candidates that satisfy the diversity constraints is highlighted in pink, with a total score that happens to be 373. If we consider the selected set more closely, we observe a problem, however, and that is that we picked the best according to score, white and male candidates, A and B, but we did not pick the best Black, Asian, or female candidates. And note that my example was deliberately constructed to highlight the following point. If some population groups have systematically lower scores, then it costs less to skip their best scoring members in the name of diversity. And this runs contrary to the nature of the diversity objective, which is to equalize access to opportunity. It also represents unfairness under a particular belief system that I'm making explicit here. Suppose that scores represent effort. For example, how hard someone had to study to do well on a test. We may take a relative view of effort and assert that scores are more informative within a group than across groups. Further, we may assert that it's important to reward effort. If you study more, you should have more of a chance to succeed. Taken together, these beliefs correspond to a particular version of substantive equality of opportunity, namely luck egalitarian conception of equality of opportunity. This is a notion from political philosophy, which I'm showing here, denoting here with a rainbow unicorn. So there is something we can do though, if we consider this in fact to be a problem under this particular belief system. And that is, we can choose a different set of 4 candidates. These are the candidates that I'm highlighting in blue. This set still meets the diversity constraints and its score is just marginally lower than the score of the pink set, so utility loss is small. And this blue set now contains the top scoring candidates of both genders and the top white and Black candidates. And so it's much better in terms of rewarding effort across groups. Having stated our beliefs and observed the trade-off between diversity, utility, and a particular kind of fairness, we are now ready to design an intervention that would compute a set like the blue set for us. For example, we may phrase unfairness for a particular group, like the female candidates, as the ratio of the score of the lowest scoring selected candidate, that is K with score 83, and the score of the highest scoring skipped candidate, D with score 95. We can then formulate the selection process to balance unfairness across groups. And there is a paper that I'm referring to here where we did this and a lot more. We considered several different fairness metrics of this sort, and then used them both for set selection, like getting the top K, and for ranking. And we devised an integer linear program to encode all of these constraints and ran some experiments to show that, in fact, utility cost of balancing fairness is low in most cases. As another, somewhat more intricate example, consider a data set of candidates with specified gender and race, shown here as a table. This dataset is used by a moving company to hire K = 4 best qualified candidates. These are going to be candidates B, C, D, and E. And note that the score attribute X represents a candidate's weightlifting ability, and higher is better. The outcome Y represents the candidate's final qualification score, based on which they are then selected. Candidates are ranked in decreasing order of Y. The process by which Y is derived is hidden from us, but we do observe each applicant's attributes, including their score X. We may have reason to believe, based on our knowledge of discriminatory practices in hiring, that gender and possibly also race impact the qualification score Y. So we state our beliefs, and this is the problem. We state our beliefs in the form of a structural causal model, SCM. And SCM is a directed acyclic graph where vertices represent observed or latent variables, and edges indicate causal relationships from source to target vertices. The arrows pointing from sex, or gender, G, and race, denoted R, directly to Y, encode the effect of direct discrimination. We want to check whether such links exist in our data, and if so, to break them. They are shown in pink here to say that we don't want these links to exist. Additionally, the SCM can encode indirect discrimination. G and R both impact Y through weightlifting ability X, called a mediator variable. So the question here is, should we or should we not allow gender and race to impact X?
Julia,
yes.
These SCMs, you construct them based on the hypothesis that you want to check?
That's a great question then. So the SCMs, they encode our beliefs. An ACM actually makes a statement about what I think some of the effects are in society in terms of what variables impact what and which of these effects are legitimate. So you will notice that in this example, my beliefs were just stated in words, right? I said scores are more informative within a group than across groups, and it's important to reward effort. So here I'm formalizing a belief system of this kind in the form of a structural causal model with nodes and arrows, and specifically highlighting some of these arrows, saying I don't want any signal from G to Y directly and from R to Y directly. And what I do with signal from G and R through X to Y, I'm going to decide. And there's some flexibility on that. Does this make sense?
Yeah, thanks.
Right. So, and we like SCMs, of course, right? Because they are graphs. We can see that they can be used as computational objects. And also they allow us to explicitly state these constraints. So there is this transparency angle here. That's very important. And in particular here, we have the flexibility to state that if impact of race on X is determined to be in effect in our data set, then it should be disallowed. There's no reason why there should be perceived differences in weightlifting abilities between races, for example. And on the other hand, the impact of sex on weightlifting ability can be considered legitimate. And we know this from biology, right? On average, women are able to lift heavy weights less well than our men. And the SCM on the right here encodes these beliefs. In it, X is treated as a so-called resolving mediator with respect to gender, but not with respect to race, as denoted by the color of the corresponding arrows. Now, how do we use our beliefs stated as a structural causal model to inform an intervention? How do we change our actual computation? The idea is to compute scores, treating each individual in the sample as though they had belonged to one specific intersectional group. And in this case, that could be Black women, because this is the group that is more than doubly disadvantaged, essentially, is the argument. And then rank on those scores. In a nutshell, a counterfactual score Y is computed by replacing the observed value of a sensitive attribute, for example, white male, with the counterfactual, black woman, and then propagating this change through the DAG, through the structural causal graph. Any directed descendant of gender or race has its value changed by computing the expectation for the new value of the sensitive attribute. And this operation is iterated until it reaches all the terminal nodes that are descendants of any of the sensitive attributes. If a mediator variable is non-resolving, then its value will be set to the counterfactual value in the process. If it's designated as resolving, then we keep its observed value, meaning we allow that influence. The resulting ranking will be counterfactually fair per our definition, and we will use it to assign outcomes. So for intuition, you can imagine that all individuals in the data who have sufficient weightlifting ability, whether they are men or women, white, Asian, or black, they would all look in this process like Brienne von Tarth, from this character from the Game of Thrones, only darker. And she is actually this knight that is wielding the data equity swords. So a darker version of Brienne von Tarth. Additional details about how this problem is set up, how we actually compute these counterfactuals, as well as experimental results that showcase the flexibility of our proposed method can be found in the paper that I'm referring to here. So now let me switch gears and very quickly, because I want to leave time for a discussion, discuss access equity and then outcome equity even faster. So access equity, what is it? Just to remind ourselves, it's concerned with having access to information such as features, data, and models that are needed to evaluate and potentially mitigate inequity. The point of view that I will take here is primarily of mitigating, detecting and mitigating technical bias, and that is making sure that we are able to catch and correct the imperfections and distortions in the data as it travels through complex data science pipelines. And indeed, much exciting work remains to be done to support access equity, both in terms of practical implementations and informing a conceptual understanding of the interactions between pre-existing and technical bias and their impacts on equity. The fair machine learning community considers many of these problems to be out of scope. Their focus is on predictive analytics that take as input a nice, clean rectangular data set shown on the top left. Then they crunch it and produce a result. And if we then notice that the result is such that no women are shown ads for high-paying jobs, for example, or no Black candidates are invited for job interviews, then we have three choices. We can tweak the model, tweak the data rather, for example, upsample or downsample subgroups. We can tweak the algorithmic box, for example, add a regularization term, or we can tweak the result, for example, reassign outcomes. And this is a useful exercise, but it's a limited view. I'm showing it here as fighting a paper dragon. And what I propose is that we should expand our scope and start asking what specifically happens inside the box, how results are used, and more importantly for the conversation here, where did the data come from? And of course, this question, and me highlighting this question is not surprising, because like Temis, I'm a member of the data management community, right? So this is something that we see as well within our scope of modeling and intervention. So in other words, I'm advocating for taking a life cycle view of equity. So let us see how this may work, again, in a concrete example. So here goes. Consider Anne, a data scientist in a human resources department at a large retailer. She is tasked with developing a model that predicts the level of compensation to offer to successful job applicants to make sure that they are indeed successfully hired. Anne is going to include self-reported demographic data together with employment histories as input. She will follow her company's best practices and split the data into training, validation, and test. Then she will implement data pre-processing, join a bunch of tables, and then she will interpolate missing values. After that, Anne will perform model selection and finally tuning and validation. So nothing unusual here. Next, Anne is going to consider the accuracy of the trained model, and she will observe a disparity. Accuracy, predictive accuracy, is lower for female applicants. They are, in fact, being offered salaries that are lower than what they would find competitive. And this presents a particular kind of a fairness issue. Now, considering the complexity of this data processing pipeline, Anne has a long night of debugging ahead of her. So thankfully, Anne has a hunch. She goes back to data pre-processing and observes that the value of the attribute age is missing far more frequently for women than for men. And she interrogates data interpolation, filling in missing values. She compares age distributions by gender and notices differences starting from the mid-30s, meaning women are less likely to say how old they are, and the older people get, the less likely they are to say how old they are for the purpose of employment. Anne revisits the data cleaning step and selects a different data imputation method than the default one that she was using to fill in age in applicant demographics. And her classifier works better. So extrapolating now from Anne's experience, I'm going to list some other sources of technical bias, technical choices that people make in pipeline construction that may arise during data cleaning due specifically to incorrect modeling assumptions. Consider a form that gives job applicants a binary choice of gender, and it also allows to leave gender unspecified. Suppose that about half of the applicants identify as men and half as women, but that women are more likely to omit gender for fear of discrimination, perhaps. Then if mode imputation is used, that is replacing a missing value with the most frequent value for the feature, which is the default in scikit-learn, then all predominantly female unspecified gender values will be set to male. And more generally, multi-class classification for missing value imputation typically will only use the most frequent classes as target variables, leading to a distortion for small population groups, because membership in these groups will never be imputed. Now, next, suppose that some individuals identify as non-binary. Because the system only supports male, female, and unspecified as options for input, these individuals will likely leave gender unspecified. If mode imputation is used again, then their gender will be set to male. A more sophisticated imputation method will still use values from the active domain of the feature, setting the missing values of gender to either male or female. This example is very simple, and it illustrates that technical bias can arise from an incomplete or incorrect choice of data representation. Importantly, it has been documented that data quality issues, such as missing data, often disproportionately affect members of historically disadvantaged groups. And so we risk compounding technical bias due to data representation with pre-existing bias for such groups. In a recent line of work done jointly with the very talented Stefan Grafberger and Sebastian Schelter, we developed a tool called mlinspect. It's a lightweight data distribution debugger for pre-processing pipelines. mlinspect extracts logical query plans, modeled as directed acyclic graphs, shown on the right, of pre-processing operators from machine learning pipelines that use popular libraries like pandas and scikit-learn. And it combines relational operations and estimator transformer pipelines. These plans are then used to automatically instrument the code and trace the impact of operations on properties like distributions of sensitive groups in the data. In a related line of work, Sebastian Schelter and I, together with several of our students, built FairPrep, and that's a system that supports data scientists in their day-to-day battles with technical bias by enabling sound experimentation. FairPrep helps incorporate new components, such as data pre-processing methods and fairness-enhancing interventions, into complex data science pipelines, and quantifies the effects of some of these components on multiple objectives, including accuracy and fairness of the classifiers that make part of the pipelines. I know that I'm running out of time and I do want to leave some time for discussion, so very quickly, perhaps let me spend 2 minutes on the final dimension of equity, and that is outcome equity. It's concerned with whether and how we can assess and mitigate inequities that are outside the system's direct control. And my thinking about outcome equity centers around interpretability and public disclosure. I like to think about these terms using the nutritional label metaphor. The data management community has been studying systems and standards for metadata, provenance, and transparency for decades, and the needs of data equity systems are once again bringing these favorite topics into the spotlight, but with a twist. To differentiate nutritional labels from more general kinds of metadata, we articulate several properties, and these are that labels should be comprehensible, short, simple, and clear, consultative, providing actionable information, for example, advising a job applicant what qualification exam to take to become more competitive for a similar job in the future. They should be comparable, implying a standard, and computable, computed incrementally, constructed incrementally through complex data-driven processes that lead to decisions, such as whom to hire and whom not to hire. The thinking on nutritional labels coincides with some of the work that I do and that is arising throughout the world, as in the United States also, on how to regulate the use of data-driven algorithmic systems that, again, I'm calling ADS. So in New York City, we are currently considering a bill that would regulate the use of automated employment decision systems by making them subject of an audit for bias and also disclosing to candidates when they apply, when such tools were used, and what job qualifications or characteristics the tool used to make the decision. And if you'd like to find out more about what I think about this proposed bill or regulation of hiring systems in general, please take a look at a recent New York Times opinion piece that I co-authored with Alexandra Reeve-Gibbons and Hilke Schellman. I'm highlighting some points here. And I also very recently wrote a piece on nutritional labels for job seekers in particular as a useful method for disclosure, and it was published in the Wall Street Journal. Here's an example of what such a label may look like for the application part of the process, when a job seeker decides whether or not to apply for a position depending on the qualifications, on how their data will be analyzed, and what types of assessment the company will use. I call this the posting label for job posting. I'll skip this. I'll mention that as part of outcome equity, I think it's important that we educate students and also much broader stakeholder groups on responsible data science. Here I'm showcasing a course that I developed called Responsible Data Science at NYU. All materials are publicly available online. Please use them and let me know what you think. And I have also been developing a comic book series together with the very talented Fala Arif Khan, whose images, graphics you've been seeing throughout the presentation today. The series I'm showing here is called the Data Responsibly series. The first volume has been translated from English into Spanish and French. The French translation is done by my dear friend and colleague Serge Abitboul. Please take a look and enjoy. And we also are doing work on public education courses. We Are AI is a course that we are about to pilot together with the Queen's Public Library in New York City. And it also comes with a comic book series for the general public. It's a 5-volume series called We Are AI. So please take a look at that as well. Let me know what you think. And to wrap up, I gave a perspective on data equity systems. I grounded it in a discussion of automated hiring tools. It's a specific use case that gave us ample opportunity to both appreciate the potential benefits of data science and AI, but also to get a sense of the ethical and legal risks. It's clear to me that technology has an important role to play here, but to make progress, we need to step outside our engineering comfort zone and start reasoning in terms of values and beliefs. in addition to checking results against known ground truths and optimizing for efficiency objectives. This seems high risk, but one of the upsides is being able to explain to our children what we do and why it matters. We cannot automate responsibility fully, and lots of stakeholder groups are responsible for making sure that these systems are developed, designed, and used responsibly and socially sustainably. And I see the role of technologists such as myself in helping build systems that expose the knobs of responsibility to people rather than automating us into responsibility. And of course, these systems we're developing are not purely technical. They are social, legal, technical. And so to expose the knobs of responsibility to people, we must work together to create meaningful regulatory mechanisms, a topic on which I touched briefly today, but didn't have time to discuss. And I also see as part of our responsibility as technologists and educators to help create a new generation of AI practitioners and an informed public. Thank you very much.
Thank you very much, Julia, for this very interesting talk. Also with these very nice illustrations, I should say. So are there any questions for Julia?
Hi, I have a question. Hi, Julia. First of all, I'd like to express my great thanks to your great contributions. I am Asian and I am also proudly gay, and I think what you have done is really boosting social justice. In fact, I have been doing some social justice work outside of my work at with SAMIS. And on your talk, I'd like to ask, could you? I'd like to ask about the intersectional part. I don't know whether this technical solution, in this technical solution, have you considered the intersectionality in sociological terms? For example, maybe we have race, we have sex, but in the meantime, these two can intersect. So, for example, in your example, actually, the Black women or the Asian women are somewhat more disadvantaged than their male counterparts or their white counterparts. Have you considered about this in your design of your algorithms? Thank you.
Thank you very much, Edward, for this excellent question. And in fact, the two technical pieces that I showcased, and of course, I didn't have time to go into details, specifically are aimed at surfacing intersectional discrimination effects. So this is really a very, very important observation, right? That even if we have information about people's membership in various protected groups, for example, based on gender and on race, right? Simply stating our fairness constraints with respect to intersectional groups, like admit enough Black women into college, is not going to do the job. And this is both because it may not be feasible to state such constraints with respect to every group, right? So the legal system in the US, for example, says, don't discriminate against women and don't discriminate against racial minorities. But there isn't a clause that says don't discriminate against Black women. And an additional complication here is that people are more than doubly disadvantaged. This disadvantage is more than additive by being a member of multiple disadvantaged groups. And so what we're doing in both of these lines of work is we are explicitly actually modeling and addressing intersectional concerns. So in the first paper that I discussed, we said, yes, we have the various constraints on representation, right? But if you belong to multiple groups that are protected, then your chances of being not offered the position, even if you are qualified, are higher, right? So this is what we're trying to control for, is to making sure that people are treated fairly in the sense of their effort is being rewarded in a relative sense with respect to every group to which they belong. And the second paper that uses structural causal models is actually, the title of that paper is Intersectional Causal Fairness in particular. So I'd love to hear what you think about it once you've had the chance to take a look. But really, these models are there to capture the intersectional effects explicitly.
Thank you. I'll definitely go take a look at your paper in much more detail. Thank you very much.
Wonderful. Thank you.
I guess that was one of the purposes for Julia to give us an overview of the different issues in this area and of some of her work. And then if we need more details, we can definitely dive in. Are there any more questions? Actually, I have a question, Julia. So I was thinking whether there is some kind of tension or trade-off between meritocracy. So I want to pick the best candidate for the best candidates for my position, and diversity or inclusion. So I have to include people from different groups. So is there a tension between these two, and what should the right balance be?
Yeah, so this is the trillion-dollar question, and there's no one straight answer, right? So the main point here to observe, and this is this whole bias in the data conversation, right? And the data as a mirror reflection of the world, is whether in fact you consider the score that you observe as a true reflection of a person's abilities. That's part A, right? So for example, is a child's SAT score, a score on a college entrance exam, in fact a function of their ability, or is it a function of their parents being able to afford tutors, right? So that's A. And part B is whether at the point when you're making that choice, that is the point of a competition, you in fact are concerned with people's abilities as they are now, or if you want to offer developmental opportunity to them. And the answer to that question depends on where that point of competition falls. If that is for employment and your company is looking for people who really have the particular skills, has no time to train them, and it needs to get people who have scored a sufficiently high number of points on a particular test, then this business necessity argument can in fact be used to excuse discrimination, meaning not admitting people even in proportion to how they apply according to their demographics. But in many of these situations, most employment situations, certainly in college admissions and school admissions, we're not just interested in how good people are now, right? We want to offer people developmental opportunity. And so if you buy the argument that people were not given equal access to developmental opportunity, then you would not take their scores, that utility, right? That meritocracy kind of a reflection at face value. So the way that you would phrase a meritocratic argument is the way that the substantive equality of opportunity framework phrases it. And that is, we need to make sure that people are given equal opportunity to succeed. Their effort does matter, right? But even the view of effort can be considered to be relative, meaning if you grew up in a housing project, probably your environment didn't really incentivize you to study as hard, right? So what you want to do, again, if you subscribe to that view, is to take the top scoring people from among each comparable group somehow. Now the question becomes, how do you create such groups, right? And it actually becomes very difficult to split people up into groups of people who are comparable. And this is the kind of conversation that goes on in everyone's heads who think about equality of opportunity, substantive equality of opportunity, and where the people in the conversation are roles and roamer and working. And so how you operationalize the different frameworks then becomes a question. So our answer has been to use causal models because that's the most flexible, and that somehow doesn't make it so that you have to really separate people into types. But it's a very difficult, intricate, and interesting question to think about.
Yeah, thanks very much. Is there maybe one last question? If not, we can close the session. Okay, so like I said earlier, Julia has been working on these issues with New York City. So this means that she has been applying these ideas on the field, and this is what makes all this discussion and her opinions more important. So let me once again thank her a lot for taking the time to be with us today. Thanks a lot, Julia, and everyone that participated.
Thank you.
Thank you. So have a great day to everyone.
Thank you very much.
Bye-bye.
Thank you very much.
Bye. Thank you.
Thank you.